let's discuss the final part. We built the model using all the tools provided by Autodesk Inventor and Woodwork for Inventor. The final part of this process is to generate the information needed for both production and its management. This involves generating various types of specifications. To understand in detail the information we manipulate, here are a few introductory words about the information generated by Woodwork for Inventor. It's important to recognize that Autodesk Inventor is responsible for creating geometry, which in the furniture industry extends beyond simple parts. A part is often viewed as an assembly containing multiple elements which we do not model due to time constraints and model complexity. Woodwork for Inventor, therefore, can interpret the same model quite differently, recognizing that a part typically includes a main blank shaping the entire piece along with several overlapping blanks, each made of different materials. Based on the geometry created, Woodwork for Inventor automatically calculates the dimensions of all workpieces and the part itself. This automation spares designers from having to manually determine dimensions from drawings, a significant advantage for cabinet makers. When revisiting the model created by Inventor, we first attribute materials using Woodwork for Inventor, which differentiates the Inventor model. We can also assign different finishes to the model, such as edgings, veneers, or paints. Woodwork for Inventor adeptly differentiates among these various elements. It calculates the dimensions of a workpiece, adjusting for any applied finishes like cants, which require subtracting their thickness from the workpiece dimensions unless they introduce specific quirks or altered textural directions. Further, if the part has a designated texture direction, this too can affect dimensions, as the calculation considers the textural orientation, allowing users to control both the texture direction and workpiece dimensions. For parts requiring technological machining, mere dimensional calculations are insufficient. Technicians need to apply additional tolerances to facilitate technological processes, which are included in the specifications, particularly when it involves cutting, leaving room for further operations. Now, let's examine the generated reports, based on the principle of templates. Users can create their own report templates which are then populated accordingly. These templates can include a variety of information necessary for production, and users can modify them as needed. One common report type is the structural specification, which reflects the structure seen in Inventor. It details the dimensions, quantities, and materials of parts. Another widely used report type is the list of cut parts, essential when importing data into cutting applications, often imported into programs like CATwrite. Additionally, the Bill of Materials report indicates the total material quantities needed for production, a critical resource for supply departments or cost calculations. This flexible approach demonstrates how our customers use these templates to generate various reports needed for their applications, allowing for an adaptable organization of information across different operational needs.